Hey there, and welcome again. In this lecture we'll be picking up with the projectiles that we're doing. We're now moving on to the power up fire, so this will be when we have the power up in the game. Before I jump into blueprinting this with you, I wanted to give you a challenge right at the beginning of the lecture this time. So this will be slightly different. It should still be fairly simple though. The only thing I want you to do, we need two things in the power up fire. I want you to give it two different inputs. So like with the primary fire, it needs a spawn location, which will need to be a scene component, and I want it to have an integer, which will be for the number of shots. So a variable called number of shots of type integer, and another spawn location variable of type scene component. So that will be the two inputs we need for the power up fire. So if you pause that here, give it a quick go, shouldn't take very long, and I will see you when you finish that. Okay, so hopefully you've done that, and if we go to the power up fire now, another thing I didn't mention is that we can also add the inputs by selecting it from here rather than going into the function itself. And I said we want two things. So we want an integer. Well, we already have the scene component, so this probably did the first part for you if you still had the project open. So we have the scene component, and all you needed to do was call this spawn location. So that's the first half of your challenge done. And the second half simply comprised of pressing new. We want this to be of type integer, I said, and we want it to be called number of shots. So there we go. We now have our two inputs that we need for this function. And we can get this started before blueprinting on it. So we know that the spawn location will be our spawn location, our projectile spawn. A number of shots will be a number we give this. So, and the number of shots I want it to have is 4. So this, when you've got the powered up fire, so when you have the powered up fire mode, this means it will be firing 4 shots. It will be like a spread shot rather than the single shot setup that we have for the primary fire. And just for cleanliness, what we'll do is now that we've plugged that value in, we're going to right click on the pin, promote to variable, and we'll call this power shot count. The good thing about doing it this way, just to remember, is that we now know what the value wants to be. We want it to be 4, and if we have already filled that, when we compile this, it will have the number 4 already in our stored variable. So that saves us a bit of time really. So that's everything ready for the power up fire, so we can now start blueprinting this if we go into the function. Now this one's a little bit more complex, but I'll try and explain it as I go along. So the maths behind this is still fairly simple. It's just more of a case of getting your head around what a for loop will be doing, and that's something that we haven't addressed before, so I'll have to explain the for loop too. But I think as soon as we've got our head around that, everything should make a fair amount of sense of what's happening. Okay, so the first thing I think we want to do is, I'm just going to drop down the spawn location, because the way that we're going to be blueprinting this is going to be tidier if the spawn location is the bottom node. It doesn't make a whole lot of difference, but you'll see why. There's going to be otherwise a lot of intersecting wires. So drop that down and press the down arrow. There we go. And that will just drop that pin down below the number of shots pin. And the reason being is the first thing we want to do is divide an integer by an integer. And we want this to be a number of -2. And then we will promote to a local variable. And what a local variable is, notice that it's not appeared in the variables here, it's appeared in the local variables, which means it will only be accessible, this offset is what we're going to call this, will only be accessible in the power up function. So if we just double click on this and call this offset. And the reason being is that we're going to use something very similar in a different function, and we don't want them to be interfering with each other. So when we do the rocket fire, if we use something called offset in there, we don't want that to affect the offset value in the power up fire. So if we make that local, that means only power up has access to this offset, even if we call it the same thing somewhere else. And this is purely because I know you could simply rename the other thing, but when they're doing exactly the same, when they're representing the same value really, there's no reason to rename it if you can just do that it just makes more sense that way when you come back and look at it. So if we pull this up, and we're just going to drag off that pin and connect the set variable to the offset. So what we're doing is we are getting the number of shots divided by -2. That means that we'll make this a minus value when we first come into here. And we are going to then get the offset and enter into a for loop. So the for loop is the new thing that I mentioned, or maybe new to some of you. And what a for loop will do is we're going to plug in the number of shots as the last index, and the first index will default to 0, but we're just going to represent that with the number 0 now. So I'll try and take a few minutes to explain what a for loop is to anyone who's new to programming. So a for loop is essentially a predefined function which will start from a value you give it, which in this case is 0, and if you don't give it an argument it will always be 0, and it will iterate, so it will loop around until it hits the last index, and it will then normally perform some kind of functionality or increment check each time it goes through a stage of its loop. So for example, at the moment the value that we've placed in we know is 4, so we've given it a number of 4 for the power shot count. So it will go from 0 to 4, and quite simply we'll get it to do something each time it goes through. So when it's at 0 it will do its first call, and then when it goes back around it will get to 1, it will do the same thing a second time, and then the third time when it gets to 2 it will do the same thing again, and then when it gets to 3 it will do the same thing again, and then finally when it gets to 4 it will do that same thing one last time, and it will then exit the for loop. And that is the other thing, is I should also take a moment to explain why we've chosen the number 4 and how a for loop uses that, and why that in fact means that we will be firing 5 projectiles. So that may confuse anyone who has never done any programming before, because it's a very strange logic to address the first time round. So the way this is looked at is fairly similar to an array. An array starts from the 0 index, or the 0th index, and it will, as I said, go up to the final index you give it. So this isn't just going from 1 to 4, this is in fact going from 0 to 4. So if you only wanted it to have 4 projectiles, you'd need to put in the number 3, because 0 will be the first projectile, 1 will be the second projectile it fires, 2 will be the third, 3 will be the fourth, and 4 will actually be the 5th projectile it fires. So that's how many times it's going to go through this loop in that sense. So this is why when we get around to doing this, you'll see 5 projectiles actually appearing rather than the 4 you might initially expect. So that's something very important to keep in mind whenever you do a for loop, is to always account for that extra value, because we start the loop at 0. And now one thing you might be tempted to do is just change this to 1, and that's fine, that would work. That would get you a loop of 1 to 4, which would give you 4 projectiles. The only problem is you would kind of be teaching yourself the wrong way to program. Logically it might seem like the right thing to do, but if you were to use other people's code, or people who have been programming for a long time, then you will find that they follow this 0 to X rule, which means you'd then have to readapt to how they're doing it, and their logic may be off to you. So I would say the easiest thing is to kind of forget the preconception that a number will go from 1 to something, and just get used to this 0 to X logic. So hopefully that makes sense why we're going to approach it this way, and hopefully that makes sense what it's doing. If not, then do get involved. This is one of the things that I know new programmers can struggle with. So get involved in the chat, help each other out, or contact me and I'll be happy to try and find other ways to explain it outside of the video, so that we can get back and focus onto the next part of this function. So with that done, we now have a conceptual idea of what the for loop is doing, and we will then, each time we do this, so remember we're doing this 5 times, we will do what we did in the previous primary fire, and we will spawn actor from class. So it's very similar, but the only difference, as I said, is we want a multiple number of projectiles. So this is how we're going to get them. And I'm going to do the same thing again. It is going to be a bit strange, but we'll just use the bpPlayer. And then down here, we're going to do some interesting maths to get some cool offsets to our projectiles. So we're going to get the world transform. So again, that's going to be the world transform of the projectile spawn. So that will be relative to where the player's moved. So it's always appearing in front of the ship. We will break the transform, and we're breaking it for a different reason this time, is because I'm going to make an arc of projectiles. And we want to split the structure pin for the location. We want to make transform on the other side, so get a make transform. We're going to split the location structure on that side. Going to have to move that across, and see that won't fit. And we can plug the X and the Y straight across again, we don't need to change those. For the Z, we will plus a float by a float, and we're going to plug that over there. And then down here we're going to times a float by a float, or multiply a float by a float if you prefer. And what we'll be getting is a fairly arbitrary number, but 5 will be the distance between the projectiles. That's what this number represents. And we will take the offset, so we have our offset value down here. We're going to get that, so control and drag that in, and just plug that in here, and this will convert an integer to a float. So kind of like what I mentioned in the first example blueprint we had, where it converted an integer to a string. This is doing the same thing again, so it's taking a whole value and it's turning it into a float value, so it will just make that 5 point something, but it just needs that so that it can be part of the location, because the location takes a float or 3 floats and not an integer. So this is taking whatever the offset is, it's timesing that by 5, which will give us a distance of 5 between each projectile. And then finally, with this value we have here, we just want to break the rotation as well, so we're going to split the structure spin for the rotation. We can leave the rotation here for 0 for all of these, and the only one we want to change is the roll this time, the X. So we're going to change the roll rotation. So this means that we'll add an offset between each projectile, and we'll change the rotation a little bit so that they're looking in different directions, so that they kind of fan out as they move forward across the world. Now with that done, we're going to go back up to the spawn actor blueprint. We are going to plug in the return value into the spawn transform, and finally we will set the offset. So we're going to get the offset again. I'm going to set this to a new value, and what we'll do is we'll get the current offset, so whatever the offset is at the moment, and we're going to plus an integer to that. We'll just plug that in there. And I realise this may not make a whole lot of sense to some people at the moment. What I will do, I have a lecture planned to try and keep this separate for the people who do know what's happening. I'm going to try and move on now, but I have a lecture planned in the future where I'm going to debug through this, and we'll go through one node at a time so we can see exactly what's happening. As I mentioned in the earlier lecture, I think that's a really good way to learn anyway, and I'll kind of show you what I meant by that. But yeah, we'll go through one node at a time, and this will all unfold. All of these values, you'll see them increasing and changing in a specific way as we go through, and hopefully that will make sense of what this is all doing. But I'm going to leave this here for now. Just know that this is fanning the projectiles out. As the for loop increases the value, it will change the offset, it will do the equations that we need down here next time we run through the loop, so each one will have an offset of position and rotation. And if we go back now to our event graph, we now have this set up. If we change this boolean down here, kind of like a quick cheat system for us, we can tick this and give it a has power boolean to true. This means our projectile will now not fire the standard projectile. It will now go into the power up projectile function. And the only thing we need to change again is to make sure that we always spawn and ignore collisions. If we go back and play, there you go. It's not very clear because I'm not using a very good, we don't have a projectile yet, but you can see that each of the ships which are coming out, the rotation is slightly different, so some are looking up, some are looking down, and some are looking straight ahead. And that's what I mean by we're adding a small offset to the rotation and the location. We'll just see quickly if there's anything which will better demonstrate this. I don't think there's any simple objects. So again, this will become a lot more apparent as soon as we have the projectiles set up. I don't want to break away from creating the player functions yet, but we will come back to this, change this to be a projectile, and that will show a lot better what's happening. So I'll leave that here for now. We do have the powered up projectile set up and ready to use when we've got some more of the blueprints available though. So I think that's pretty cool. We're one step away from having the projectiles completely done for this player. So I'll leave that here, and I will see you in the next lecture.